Okay, sanibonani, Mageba lo, umntwana, ubuyile. I'm back guys with another Euclidean geometry, grade 11. Today I'm doing theorem 7, where we are talking about tangent. Tangent, different types of, there are three. We have tan, perpendicular, radius, and we also have where we have two tangent, and if those two tangents are equal, then we have something, but we'll talk about that one. And also we have tan chord theorem, but on this one we will cover two types of the tangent in terms of theorem. The first one that we are going to do is a tan perpendicular radius. What does this one saying? It's saying a tangent to a circle. A tangent, what is a tangent first? A tangent is a line that touches, it's either a graph or a circle or anything, but it touches it once. That is a tangent. So they're saying a tangent is a circle. Tangent to a circle is perpendicular. What does perpendicular mean? Also, it's mean perpendicular. We have something that is 90 degrees. That's what perpendicular is. So a tangent to a circle is perpendicular to a radius. What is a radius again? A radius is a line from a center to a circumference. From a center to a circumference, that is a radius. So what does this theorem say? A tangent to a circle is perpendicular to the radius at the point of contact. This is the point of contact. That's where it's perpendicular. What does this mean? If this is P1 and P2, then P1 is 90 degrees and then P2 is 90 degrees. What is a reason for this? It's just a tan chord. Not tan chord, it's tan perpendicular radius. Tan perpendicular radius. That's the reason about this one. It's tan perpendicular radius. I hope you understand it. I hope you do. So what is basically saying that if APC is a tangent to a circle at at B, then the radius OB is perpendicular to APC, then P1 and P2 are just 90 degrees. That's what basically saying. There's no need of any proof in this theorem. It's just when we have a radius and a tangent, P1 and P2, they're 90 degrees, tan perpendicular radius. That's the theorem. And then converse theorem of this one. Now this converse is gonna being applied, or is to apply if you need to prove that we have a tangent in that particular circle. You need to prove that something is a tangent or a line is a tangent. Then you have to use, this is one of the things when you need to prove a tangent that you are going to use. If a line is drawn perpendicular to a radius. Now if a line, this line APC, it's drawn perpendicular. Something important, this if a line is drawn perpendicular to the radius, this line is drawn perpendicular to this radius at the point where a radius meets a circle. At the point where a radius, meaning from this OB, which is our radius, meets a circle here, it's meeting it here, then a line is a tangent to a circle. Then the line APC is a tangent to a circle. That's what basically it's saying about a converse of theorem number 7, where you are proving that APC is a tangent we still gonna touch the tan chord theorem, where it's also one of the things that you need to prove when you are proving a line with a radius. So that's what theorem number 7 is saying. It has tan perpendicular radius, we have a tangent, and we have a radius, and then the angle is here is just 90 degrees, tan perpendicular radius. Thank you so much. Okay guys, now I'm just gonna do the example of the tan perpendicular radius. We are going to apply it. Another thing that it's important here, you must remember the theorem that we have already deal with, theorem 1 to theorem number 6, and this one that we are doing now, which is theorem number 7. So if O is a center, from theorem number 1, number 2, and number 3, something you must have radius. If O is a center, you need to check that you do have radius. OC, it's a radius. OB, it's a radius. But now these two radius, they pass through what? A center. They pass through what? A center. Then what does it tell you? What does that mean? It means if it cuts through the center, then we cut through a circle here too. So we have two circles that have been cut. We have one circle cut into two parts, meaning we do have a semicircle there. What does semicircle mean? Meaning we have this angle here that is touching at the circumference, that is making the 90 degrees, because angle at a semicircle, we have this diameter here. If we have this diameter here, and when we have this triangle here, and then this triangle, at this point it touches at the circumference, all these points they're at the circumference, and this line is passing at the diameter. This diameter pass on the center. So there's this 90, this angle here, which is D, which is our Y in this case, is 90 degrees Y angle at the same sec. And another thing, now we have A, B, C, which is what? Our tangent. If we have a tangent and we also have a radius, tangent and a radius from our theorem, then this one now, it's what? It's a tan perpendicular radius, meaning AB going up, or ABO is equal to 90 degrees Y tan perpendicular radius. Then what is ABO? It's 35 plus X is equal to 90 degrees. Then X is equal to 90 degrees minus 35. Then X is equal to 90 minus 35 is equal to 55. I hope you understand that one. And then from there we have this X, which is 35. We're looking for this Z here. This is a triangle. Then Y plus X plus Z is equal to 180. Y, sum of a triangle. Y way 2 is 90 degrees. X is 35. Z, we're looking for Z, 180. Z is equal to 90 plus 35, which is 180 minus 125. Then Z is 180 minus 125, which is 55. Then we are done with our sum. I hope you understand it, guys. It's very very important. Then coming to this one now, where we still have the same statement, O is a center. O is a center. If O is a center, we must have radius there. And O is a center, then OB, the radius, OD is the radius, meaning this one is equal to this one. I hope you still see that one. And then from our theorem number 2, if O is a center, and then we saw this shape when we were proving this thing. If O is a center, this shape where this one is 2 times this one. I hope you still remember that, where O is a center, and we are seeing this shape where all our points, they touch at the circumference. Still one of the shapes. And also again from here, if this one is equal to this one, meaning this one is equal to this one, which is just an isosceles triangle. I hope you see that one. Very important. We're just analyzing our diagram. Then again, now they are saying APT is a tangent. Then if a tangent, and we also have what? A radius, meaning these two, it's what? It's 90 degrees. One tan perpendicular what? Tan perpendicular radius. I hope you understand it. And now from everything that we just said there, and we're just gonna apply them. Start from our y, since y and this one, 2y is equal to 140, y angle at the center, which is this one, is equal to 2 times the angle at circumference, then divide by 2, y is equal to 140 divided by 2, which is 7, easy from what we just analyzed from in our diagram. I hope you see that one. And we have this, and then we need x. We don't have x, but we can find this one and this one, since this one and this one, they are the same. This one is equal to this one. You can start by saying OP is equal to OD y maradi. Then if now from this we can say OBD is equal to ODB what? Isosceles triangles, and this one is equal to this one. Then from there we can find this one by doing sum of a triangle, by saying 140 plus OBD and plus this, but this one is equal to this one, but we can, so that this one, this OBD is equal to ODB. Let me just write it like this. I'll write this statement after that. P this one, and then yeah, and then equal to 180, and this is sum of a triangle. And 140 plus we are looking for this one, and also this one, which is OBD, is equal to ubani O, which is OBD is equal to ODB. So we can say OBD plus OBD